Okay, so next up we're looking at a new skill, which is called integration by parts. Okay, and this is it's actually a variation of the product rule, I think. There is a proof for this. Give me a second. Yeah, I'll show you. It's actually down here, isn't it? Yeah, this is a variation of the product rule. Give me a second. Here we go. Yes, so if we know that the product rule is if we differentiate uv with respect to x, then we end up with v du plus v u dv. But we can actually rearrange this, and it gives you the integration by parts. Now, just in terms of time, I'm not going to worry too much about this for now, but this part here is really important. Please get this part here down, the bit that's in black. This is really important. You'll see how it works in a second. Here we go. So that's what you need to get down. I'll give you a second to get that down. It's the integral of u dv by dx with respect to x is equal to uv minus the integral of v du by dx. And this is in the formula booklet. So get that down. Okay, so here's the integration by parts in the top right. Okay, and we're going to be looking at integrating this one on the left. Now, you'll notice that in our integral here, I'm just going to highlight a few things. Here we've got u, and we've got du, okay? So actually we need to integrate u. Sorry, the only thing we need to do with u is differentiate it, okay? So we need to differentiate u. If I look at v, now to get from dv by dx to v, what we need to do with that is we need to integrate. So we actually need to integrate, we need to integrate dv by dx. Okay, now the trick with this, and this is probably the most important part, is that we always want to pick u such that it differentiates to a coefficient. That's probably the most important. Now there is actually a time when this isn't the case, but I'll talk about that a little bit later. It's like a special case of this, but that's important. We want to pick a u such that it differentiates to a coefficient. Now, what do I mean by this? Well, don't forget, if we're timesing two things together, we can either do x times by cos x or cos x times by x. Those two things are multiplied together. So actually, when I'm going to integrate this one here, these are interchangeable. The x and the cos x are interchangeable. And actually, what we need to do is we need to pick or change them so that one of them differentiates to a coefficient. Now, let me do this one here, and I'll show you what I mean. So the first thing I'm going to do is I'm going to say that u is equal to x. Okay? I know that u there is equal to x. And I'm going to say that don't say that these are two things which are multiplied together. So a little bit like the product rule, but something's a little bit different because we're integrating. So I'm going to say that the thing that's multiplied by dv by dx is equal to cos of x. Okay, so when we've got two things multiplied together, we can use integration by parts. You want to pick the u such that it differentiates to a coefficient. Now let me show you what that means. If I differentiate this differentiates to du by dx, which is equal to 1. Happy with that. So I've picked u so that it differentiates to a coefficient. But when I'm integrating this one here, I know that the integration of this, sine, cos, minus sine, minus cos, I know that cos integrates to sine. So actually v, which is the integral of dv by dx, is equal to sine of x. There, like so. That's your first point, okay? And then we're going to sum all of this into this part here, which is u, v, minus the integral of v du by dx with respect to x. So we know that u is equal to x, so this is going to be equal to, in fact I should probably write it all down, this is equal to x sine of x minus the integral of v, which is sine x, times by du by dx, so it's 1, well, it's going to be sine x, let's do it in the right order just to not confuse you, sine x times by 1 with respect to x. Now the reason that we want to have a u which differentiates to a coefficient is that now I can actually, if I times anything by a coefficient, I can actually integrate this part here. So it's going to be equal to x sine x minus the integral of sine x, which is going to be should be minus cos. The integral of sine x, which is equal to minus cos of x plus c. Now be careful with that. I've done that on purpose. It's going to be equal to sine of x times by, x sine x plus cos of x plus c. Okay, there's your answer. So we've used integration by parts to integrate something when two things are multiplied together, making sure that we set the thing that we want to integrate, setting the u as something that differentiates to a coefficient. So there's that first one there. Okay, let's have a go at another one then. Now, this one here is that special case, okay? And you're going to see why I've picked the special case here. So, this is a special case. With this, we set ln of x as u. Okay, this is a special case and we set ln of x as u. So let's have a go at this one then. So I've already told you what I'm setting as u, so don't forget that it's the integral of u dv by dx with respect to x is equal to uv minus the integral of v du by dx with respect to x. That's the integration by parts. Now, what I've said here is I said to swap these round. So instead of doing integral of x squared ln x, I'm going to write it as integral of ln x times by x squared with respect to x. So this is going to give me u is equal to ln x, and we're going to see why that is in a second. And I know that dv by dx is equal to x squared. If I differentiate ln x, I end up with 1 over x, and you can see why that's really handy in a second. And if I integrate this, this is going to integrate to x cubed over 3, like so. Then I'm going to substitute into the formula, which is equal to u v minus the integral of v du by dx with respect to x, which is equal to, well, u times by v is going to be x cubed over 3 ln x. I've switched those around, but that's okay. Minus the integral of v, which is x cubed over 3, times by du, which is 1 over x. Now, with respect to x. Now, the reason that we pick the ln x, if we've got a coefficient of x, is that we can cancel at this stage, so we can actually integrate it. Okay, so let's just think about that integral now. That first part's going to stay the same. Minus the integral of, that's going to be squared, isn't it? It's going to be x to the power of 3 all over 9 plus c. Pretty much done that there. Okay, notice this is x squared over 3. That's going to raise the power is going to be x to the power of 3. Divide by 3 is going to be x to the power of 3 over 9 plus c. Let's just check. I bet they've put a third instead of all over 3. I bet you they've wrote it like this. It probably makes more sense to write it like this, to be honest. There we go. Let's just check. Yeah, there we go. I actually wrote that as a ninth. Brilliant, so we should be getting used to this now. Now, we can actually use this to integrate ln x. Okay, there's a special rule for this one here. So, get this one down, integrate ln x with respect to x. Now, the trick with this is to actually add a little part here. You've got to add 1 in, okay? Let me show you what you mean. This is like this again. This is another special case, but we can actually use integration by parts. But what you need to do is you need to add a 1 in, and you'll see what I mean by this in a second. It isn't actually as hard as you think. So instead of integrating this, what I'm going to say I'm going to integrate is I'm going to integrate ln of x times by 1 with respect to x. Now, obviously, that's exactly the same, isn't it? Anything times by 1 is just itself. And I'm going to say that u is equal to ln of x. I always set u as ln of x, or an x to the power, so it differentiates to a coefficient. And then I'm going to set dv by dx as that 1 I've just inserted. If I differentiate u, I end up with du by dx is equal to 1 over x. If I integrate dv by dx, I end up with v is equal to x. Now you're going to see why this is important in a second. So I'm going to substitute all that into u, v minus the integral of I can't remember it now, uv minus the integral of v du by dx with respect to x. There we go. So u is equal to ln x times by v, which is x, I'm going to put that in the front, minus the integral of v, which is x, times by 1 over x with respect to x. So this is equal to x ln x minus the integral of 1 with respect to x. Now if I integrate 1 with respect to x, I end up with x ln x, and the integral of 1 with respect to x is plus x plus the c. Should have had plus c down here, shouldn't I? Brilliant, there you go. So this is a little definition. Now you will need to know this, okay, that the integral, because we haven't actually come across this, the integral of ln x with respect to x is equal to, this is kind of a little proof, isn't it? X ln x plus x plus c. X ln x plus x. That's the integral of ln x. So if I'm doing this one here, the integral between 2 and 1 of ln x with respect to x, you don't need to do this again. You can literally just say that this is equal to x ln x plus x between 2 and 1. And this is going to be equal to 2 ln of 2 plus 2 minus 1 times by ln 1. So ln 1 plus 1, which is going to be equal to, what is 1 ln 1? ln 1 is equal to 0, is it? Something to the power of, what do I need to raise e to the power of to get 1? It is equal to 0, yeah. So this is going to be 2 ln 2 minus the 1. There we go. Brilliant. Perfect. Super. Let me just check. Have I made a mistake here somewhere? I have made a little mistake, haven't I? And it's up here. This here, I wrote minus, but then this here needs to be minus x, sorry. This here needs to be minus x. And does that change this? So then this needs to be minus x there. So this is minus 2. Look at that, conveniently it gives you the same answer. And then this is plus 1. That's very convenient, isn't it? So minus 1, which is going to be plus 1, so it does give you the same answer, but we need to know that. This is really important. X ln x minus x plus c. Should highlight the plus c as well, really. Brilliant. Super. Alright, now, this is a common one, and it's a funny one. I do enjoy doing these, okay? So you've got to be able to understand and try and figure out which one you need to set as u. Now, integration by parts twice, okay? You'll see why it's twice in a second, but yeah, I've seen ones where it's like 2 or 3 times actually, but we'll talk about those at a different time. So I'm trying to do the integral of this, and what I'm going to do is you need to set the u as something that differentiates to a coefficient. Now, you might think to yourself, neither of these differentiate to a coefficient, but you've got to think about the repeating. If you continue to differentiate, which one differentiates the coefficient? Well, x squared differentiates to 2x, and then 2x differentiates to 2. So that one there differentiates eventually to a coefficient. So if I'm writing this one down, I'm going to first of all say that u is equal to x squared. I'm going to say that dv by dx is equal to e to the x. If I differentiate this one, du by dx is equal to 2x. And if I integrate this, the integral of e to the x is e to the x. Then I'm going to sub it into the formula, uv minus the integral of v du by dx with respect to x. So u is equal to x squared times by v. So it's going to be x squared e to the x with the integral of, minus the integral of v, which is e to the x, and du by dx, which is 2x e to the x with respect to x. Now you think to yourself, I've got to a stage now where I can't integrate that. You've got to use integration by parts again for this part here. Okay, you've got to integrate that by parts again. So now we do it a second time, not forgetting this first part, but for this second part, I need to say u is equal to, well, which part now differentiates the coefficient? It's the 2x. Which part, so dv by dx. So this integrates to 2. dv by dx is e to the x, and that integrates back to e to the x, okay? So when I'm doing this one here, I've got to do let's literally write it out again. I'll do it in red, actually. So it's going to be uv minus the integral of v du by dx with respect to x. So u is equal to 2x times by v, which is e to the x, minus the integral of v, which is e to the x, times by u, which is 2. So it's going to be 2e to the x with respect to x. Now I can actually integrate this now. I can integrate this. So let's do that. So it's going to be 2x e to the x minus 2e to the x integrates to 2e to the x plus c. Now, take note that this is this part here. So our full integration of all of this, doing it twice, is the integral of x squared e to the x with respect to x is equal to x squared e to the x. Now it's minus all of this, isn't it? Minus all of x, 2, I'm going to put all of this, minus 2e to the x minus 2e to the x plus the c. I can keep the plus c as a plus c, which is equal to x squared e to the x minus 2x e to the x plus, it's minus minus, 2e to the x plus c there, like so. Brilliant. Brilliant. Double integration by parts. Very good. So you can see you do integration by parts, and then because you've got an integration in the integration by parts, that part there you need to use by parts again, and eventually you come to the answer which you want. Just check that. I do find these questions fun, you know. Alright. So we've got to test your understanding here. Have a little go at this one yourself. It is integration by parts twice, okay? So have a little go at that one yourself. I'm going to go through it then. So I'm going to set u as equal to x squared, and I'm going to set dv by dx equal to sine of x. So just over here, sine, cos, minus cos. So if I differentiate u, I end up with 2x. If I integrate sine, which is this way, I end up with minus cos. So v is equal to minus cos of x. Let's sub that in to u v minus the integral of v du by dx with respect to x. So u is equal to x squared, so it's going to be x squared times by minus cos of x minus the integral of v, which is minus cos, times by du, which is the 2. So let's just put here minus 2x cos of x with respect to x. So I'm going to have to do integration by parts again. I'm going to do it in a different colour for me. And I'm going to say that u is equal to minus 2x. And I'm going to say that dv by dx is equal to cos of x. In this case, du by dx is equal to negative 2. Cos integrates to minus sign. So it's going to be v is equal to minus sine of x. If I sub that in to u v minus the integral of v du by dx with respect to x, u is equal to, so it's going to be, let's start writing it all out, okay? So I'm going to keep that first bit in there now. So this is all equal to minus x squared cos of x minus big bracket uv, which is going to be minus 2x times by v, which is minus sine of x, minus the integral of v, which is, so it's going to be minus 2 times by minus sine of x with respect to x, like so. Okay, so this is equal to minus x squared cos of x minus minus is going to be plus 2x, minus again, so that's going to be minus minus 2x sine of x plus the integral of 2 sine x with respect to x, and then we've pretty much got it, minus x squared cos of x minus 2x sine of x. The integral of sine x is minus cos, so minus 2 cos of x plus c. I think I've got that. Look at that. Oh yeah, they've just put it in a different order. Brilliant. They've just put that I've made a mistake there. The integral of cos x is plus sine, so that there is annoying. Plus sine, which makes this a plus and makes this a plus. Brilliant. It's very easy to make those little mistakes in these questions. Alright, super. Alright, have a little go at that one yourself. Have a little go at this one yourself. I don't think this one's as hard actually. Have a little go at that one yourself. Okay, let's have a little go at this one together then. So the first thing you need to do is to set u as the one that differentiates to a coefficient. So u is equal to x, and dv by dx is equal to sine of x. So du by dx, so du by dx is equal to 1. Sine is going to integrate, so sine cos minus cos, it integrates to minus cos. So v is equal to minus cos of x. Let's sub that in. So it's u v minus the integral of v du by dx with respect to x. So u is equal to x, v is equal to minus cos. So that's going to be minus x cos of x minus the integral of v, which is this minus cos of x times by 1. So minus cos of x with respect to x. Now you can, if you want to, take that minus outside, so you can write it like this plus cos of x with respect to x. And we know that cos of x integrates to sine, so it's minus x cos of x plus sine of x. Now, we know that we want this between the two limits, so actually all of these should be between this and pi over 2. All of this should be between this and pi over 2 and 0. And this here should be between this and pi over 2 and 0. Then I need to sub in those values, don't I? So it's going to be minus pi over 2 cos of pi over 2 plus sine of pi over 2 minus 0 times by cos of 0 plus sine of 0. There, like so. Type all that into a calculator. I'm just going to have a little... if I type all of that into my calculator, I end up with 1. Brilliant. Super. Okay. There's the answer to that. Now, there is one more little question that I'm just going to go through. I'm going to try and get through it as quickly as I can. Okay? There's one more little question which comes up quite regularly. It doesn't come up all the time, this one, but I've seen it come up before. And it's this one here, e to the x and sine to the x. Now, the problem with this is that neither of them differentiate to the... neither of them differentiate to a coefficient, okay? So e to the x always differentiates to e to x. Sine of x differentiates all the way around that circle, doesn't it? So what we do with this one here is you set u equal to e to the x, and you set dv by dx equal to sine of x. If I differentiate this, du by dx is equal to e to the x. And if I integrate this, let's do it over here, sine, cos, minus cos, this is going to integrate to minus cos of x. If I substitute those values in then, so this is going to be v minus the integral of v du by dx with respect to x. Let's sub all of those values in. So it's going to be e to the x times by minus cos minus the integral of v to the x, which is this minus cos times by e to the x. I'm going to put the e to the x there first, actually. Minus e to the x cos of x with respect to x. Okay? So I'm going to take out that there, and it's going to be minus e to the x cos of x plus the integral of e to the x cos of x with respect to x. Now, I'm going to use integration by parts to do this part here. So it's going to be set u equal to e to the x, set dv by dx equal to cos of x, and then du by dx is equal to e to the x, and dv by dx is equal to, the integral of dv by dx, v, is equal to cos integrates to sine of x. So let's just sub all of this in. I'm going to keep it all here. So I'm going to have, this is equal to minus e to the x cos of x, and it's going to be uv minus the integral of v du by dx with respect to x. So minus the, plus uv, which is going to be e to the x sine of x, minus the integral of uv. V is sine x, and du by dx is e to the x, so it's e to the x sine of x with respect to x. Okay? Now, the thing that we spot here is that this here is the same as our starting position. Okay, this here is the same as our starting position. So when I do this, I can take this. If I say this now, this is where I'm up to. I'm going to say that the integral of e to the x sine of x is equal to minus e to the x cos of x plus e to the x sine of x minus the integral of e to the x sine of x with respect to x. So because these are the same, I can take all of this here over to the other side. So actually I've got two of them. Okay, I've got two of these. So this is actually equal to 2 integral of e to the x sine x is equal to minus e to the x cos of x plus e to the x sine of x. And then the last little part is you divide by 2. If we've got two of them, we know that this is equal to the integral of e to the x sine of x is equal to all of this divided by 2. So minus e to the x cos of x plus e to the x sine of x all over 2. They've done it half here. I'm just going to do it all over 2. Doesn't make too much difference. Probably better to have the half. There we go. Alright.